In this video, we are going to solve few objective questions from the chapter Haloalkanes and Haloarenes, Chemistry, class 12. So this is the first question. The order of reactivity of following alcohols with halogen acid is. So they have given three options and they asked you to arrange it in decreasing order of reactivity. Now we know that this is 1 degree alcohol, it is 2 degree and it is 3 degree alcohol, and we know that 3 degree alcohol reacts faster with halogen acid. So 3 will be the highest, it will react very faster than the 2nd degree, then 1 degree. So option B is your correct option. Next, which of the following alcohols will yield the corresponding alkyl chloride on reaction with concentrated HCl at room temperature? Concentrated HCl at room temperature is basically the Lucas reagent, and we know that Lucas reagent reacts faster with 3 degree alcohol. So option D will be the correct answer. Arrange the following compounds in increasing order of their boiling point. We know that straight chain compounds have the highest boiling point, so 2 will have the highest boiling point. So obviously option C should be the answer, because here they have given 2 as the highest. Obviously 2, then 3, 2, then 1, then 3. This is how they will be arranged in their increasing boiling point. Next, the conversion of an alkyl halide into an alcohol by aqueous NaOH is classified as. So these are the 4 processes that are so you have to select the option that that matches with the type of the reaction. So here aqueous NaOH reacts with alkyl halide to form alcohol, and that is nothing but substitution reaction. So B will be the answer. Next, which of the following alkyl halides will undergo SN1 reaction most easily? We know that SN1 reaction depends on the leaving group. Here I negative is the very suitable, very good leaving group, so I can easily break from the bond, and it will make this 3 degree carbocation, and obviously D will be the correct answer, because the fluorine carbon bond is very strong, and the C and I, the bond between C and I is the weaker one, so the bond can easily break. So option D will be the correct answer. So in this question, which reagent will you use for the following reaction? In this reaction, alkane has converted into chloroalkane. So basically here chlorine will be required in presence of sunlight. So option A is your correct answer. Next question, in which of the following molecules carbon atom marked with asterisk is asymmetric? Asymmetric means the compound where carbon contains 4 different groups. So option A, B and C means option 1, 2 and 3. In these 3 options, all the carbons are attached to 4 different groups. So 1, 2 and 3 will be answer. So option B is your correct answer. Next, which of the following structure is enantiomeric with the molecule A given below? So this is A, and we have to identify the enantiomer of A from the compound given. So here you have to first identify that this bromine and this CH3, they are out of the plane. If it is coming out of the plane, this is going behind the plane. Okay, now here the bromine has the highest priority, so it is priority number 1. This will have the second highest priority, the priority number 2, and this CH3 will have the least priority, third highest priority. So 1, 2 and 3, so we are going in the clockwise manner. So we have to identify that compound from the options given, where the priority order, the number of the priority groups, they are going in anti-clockwise direction. So this option A here, bromine is the highest priority group, the CH3 is the lowest, third highest priority group. So we will go from this direction, from bromine to C2H5 to CH3. So we will move anti-clockwise direction. So it is the enantiomer of the option A given. So option A is your correct answer. Next, identify the compound with a compound Y in the following reaction. So they have given a reaction. This reaction, it produces benzene diazonium chloride. It further reacts with Cu2Cl2 to produce Y. We have to identify Y. So obviously this will be chlorobenzene. Option A is your correct answer. It is called Sandmeyer reaction. Next, what is A in the following reaction? So here this benzene ring attached to an alkene is reacting with HCl. HCl, it will undergo HCl when it reacts with this compound will undergo Markovnikov rule. So HCl, H will go to the carbon with the more number of hydrogen atom, and Cl will go to the middle carbon. So option C is your correct answer. Next, question number 11. The IUPAC name of the compound shown below. So this compound is given. You have to identify the name. So from here we will start numbering. So carbon number 1, 2, 3. 3 containing bromine, 1 containing chlorine. So we will start 3 bromo, 1 chloro, cyclohexene. So option C is your correct answer. Then toluene reacts with halogen in the presence of iron chloride, giving ortho and para halo compounds. This reaction is called Friedel-Crafts reaction. The reaction is, so we have to identify the process. The reaction is, we know that Friedel-Crafts reaction follows electrophilic substitution reaction. So obviously here you will have to write, here the option B is your correct option. Which of the following is halogen exchange? Halogen exchange reactions are mainly the reaction where already one halogen is present and we replace the halogen with some different halogen. So here option A is your correct answer, because this is an example of Finkelstein reaction. So option A is your correct answer. Next, arrange the following compounds in the increasing order of their densities. We know the density proportional to molar mass, and molar mass is highest for this 4 number compound, then this third one, then this 2 number, then this 1. So option A is your correct answer. Next, aryl halide undergo nucleophilic substitution reaction with ease. So aryl halide, this according to the question, aryl halide easily undergoes nucleophilic substitution reaction, which is wrong. The carbon halogen bond in aryl halide has partial double bond character. This is correct, but A is wrong. So A correct, R wrong. Next, assertion, presence of a nitro group at ortho and para position increases the reactivity of haloarenes towards nucleophilic substitution. Yes, because nitro group is electron withdrawing group. So reason, nitro group being an electron withdrawing groups decreases the electron density of our benzene ring. That is correct. So both A and R are correct. Next, this question, assertion, it is difficult to replace chlorine by OH in chlorobenzene in comparison to that in chloroethane. So it is difficult to replace chlorine by OH in chlorobenzene in comparison to that in chloroethane. Yes, because of resonance. Yes, the reason is carbon-chlorine bond in chlorobenzene has a partial double bond character due to resonance. So both A and R are correct.